This is the San Marco Cafe in Trieste, and in this video I'm going to be walking around Trieste and talking about free will, determinism, quantum mechanics, and probably some other things. So there is this idea that many people argue that free will is some kind of illusion and that its existence is basically disproved by science. I think that's just a misunderstanding of the scientific situation. Science does not disprove the existence of free will. But why would anyone even say that? We feel as though we have free will. So what's the reason for saying that feeling must be some kind of illusion? And this goes back to basically the idea of determinism. Now, one of the earliest and most complete statements of determinism was made by Pierre-Simon Laplace in 1814. So I'm going to read to you now, it's quite a long quote from one of Laplace's works, translated into English. So this is from a philosophical essay on probabilities, 1814. So he says, "We may regard the present state of the universe as the effect of its past and the cause of its future. An intellect which at a certain moment would know all forces that set nature in motion and all positions of all items of which nature is composed. If this intellect were also vast enough to submit these data to analysis, it would embrace in a single formula the movements of the greatest bodies of the universe and those of the tiniest atom. For such an intellect, nothing would be uncertain, and the future, just like the past, could be present before its eyes." So that's one of the earliest kind of complete statements of the determinist philosophy. And if you adopt this philosophy, you're going to regard the human brain as kind of like a machine, whereby if we could analyse fully the positions of all the different component parts of the brain, and if we could put that data into a big, incredibly powerful computer, we could predict what the brain's going to do next. We might need to know the input to the brain as well, like what the owner of the brain is seeing and so on. So that's the idea, that we could look at the brain and it's just a machine similar to a digital computer or a car engine, and we can predict exactly what it's going to do next because it's all just following the laws of physics. And there's no will in the laws of physics, there's no emotion in there. So if that were to be true, it would seem at the very least as though things like will and emotion are superfluous. There's no reason for them to exist, they can't possibly do anything because the brain is just following the laws of physics, which do not refer to emotion or will at all. Now, I could spend easily several hours just enlarging on this point, because I found from talking to people about this subject that people misunderstand this idea extremely easily, perhaps because they even, I would argue, want to misunderstand it in a sense. They are afraid that if they concede the smallest of point, they're going to end up falling into superstition or something like that. But we're going to have to move on. I'm going to have to take it that you are not such a person, you understand what I've said so far. So what we want to ask is that picture actually true? So could we take the brain and analyse the positions, the momenta, the velocities, whatever, of all its component parts, and then take all that data and put it into a massive computer and calculate what the brain's going to do next? In other words, could we predict human behaviour just using equations, just using mathematics? Because if we can do that, it suggests that the brain is just following kind of dry laws of physics, and that emotion is just superfluous and there's no such thing as free will. Free will must be some kind of just illusion, because free will basically means acting freely on your will. In other words, emotion, will is a kind of emotion, or at least it belongs to the realm of emotion. Although again, you may have a funny definition of emotion, or one that I don't share, and that may not seem to be true, and I might come back to that in another video. But you can probably agree that if the brain is just following the laws of physics, then it would seem as though there's no room for free will. So I'm going to wait here at the crossing for a minute. There are some guys that are going to come up behind me, and they're having an interesting discussion about urban planning, which I found quite amusing and interesting. I hope they don't mind me eavesdropping on them. I sort of couldn't help but hear them because they're talking quite loudly.
You have to digest things.
Digest?
Yes. You can study urban planning in 3 months and apply an exam and think you know urban planning in 3 months. There are people studying urban planning for 50 years. How can you know it in 3 months?
How can you know urban planning in 3 months? There are people who have been studying it for 50 years. I would have liked in on that conversation. It sounded really entertaining. Anyway, moving on. We're asking, is the brain a machine that just follows the laws of physics? And the answer is kind of yes and no. First of all, we've got to ask, could we analyse the brain in terms of its component parts? What are the component parts of the brain? And that's very unclear. That's something that physics does not exactly make a clear statement on. So, from a certain point of view, the brain is made up of particles. It's made up of molecules, which are made up of atoms. Atoms are made up of subatomic particles like electrons, protons, neutrons. And then there are different kind of ideas about what those are made up of, the dominant one being that they are composed of quarks. But there it starts to get really hazy. And what are quarks made up of? Some people say that everything's ultimately made up of tiny vibrating strings, or maybe planes, hyperplanes, stuff like this. But when you get to that level, you're getting into a lot of physics that is highly dubious, and we've got different models that we can't necessarily really prove, and that may even conflict with each other and so on. So it's not really clear what the brain's made up of, or even if there is some ultimate thing that it's ultimately made up of, and you can't get deeper than that. But let's say we just stick to looking at a selection of known particles. Like already we're having to water down Laplace's idea a lot, but we could look at protons, neutrons, electrons, and maybe things like photons, which have an effect on the brain. So in fact there are experiments that show that people can detect even single photons entering the eye. Not reliably, but it is possible to detect individual photons, which are particles of light. And you can be sure that even a single ion, part of an atom, migrating across the cell membrane in the brain can have an effect on the brain that ends up manifesting itself in behaviour. So you really would have to be able to predict the behaviour of very, very tiny particles in order to then predict human behaviour. You would have to be able to analyse the positions and the velocities and so on of everything in the brain, and all the forces that those particles are subject to, with incredible resolution, and then put all that data into a computer, the like of which certainly does not exist at the moment. And then maybe you can analyse human behaviour and predict what a person's going to do next. Except you really can't do that for fundamental reasons. So you might say, well, okay, we can't do that now for practical reasons, but in theory we could do that. In theory, we can measure the position of everything in the brain, whatever it's made up of. We can apply the laws of physics to it, and we can predict what a person's going to do next. In theory. Okay, we can't do it in practice, but what about in theory? If we can do it in theory, in principle, then that is just as good, really, at disproving the existence of free will, because that would kind of tell us well, okay, the brain is just following kind of dry, emotionless laws of physics all the time, right? Now, we can't actually do that. Quantum mechanics tells us we can't do that, but so does, I would say to an extent, just thinking about it logically. So firstly, we're not going to be able to measure anything exactly. Consider the height of a person, for example. So I think I'm 182 centimeters or something like that. Am I exactly 182 centimeters high? No. You could say, okay, well, maybe I'm 182.5. Am I 182.5 centimeters high exactly? No. If you go on like that, trying to get more and more exact, you're going to have to develop a very, very precise definition of what it means to measure height. You're going to have to make sure that you've got a very precise definition of a centimeter, and the more that you demand from those definitions, the more accuracy you want, then the deeper you're going to have to go into the whole subject, the more demanding you're going to have to be of your definitions of what you're measuring. But you're never going to be able to state my height or anyone's height precisely, because what you'd really need would be a number that just wouldn't terminate. It would have an infinite series of digits. Now, this is the case with things that have no particularly clear relation as such, no inherently mathematical close relation, like the height of a person and a measurement unit like the centimetre. There's no clear mathematical relation there. We're just saying how many of one is the other. It's true of things like that, but it's true even of things where there is some kind of fundamental mathematical relation. So think about the circumference of a circle in relation to its diameter, for example. How many times the diameter is the circumference? The answer is pi. Pi is a non-terminating sequence of digits. If you want to write it down in base 10 or any base, you could write down a symbol pi, but if you actually want to write it down in as a series of digits, that's going to go on forever. So, and clearly you can't write down a unending series of digits. So even if we could measure the positions of all the particles in the brain, even if it was clear what particles there are in the brain, even if we could clear all that up and make the right measurements, there's a fundamental problem there with making measurements, which is that we can't make any of them exactly, because we can't deal with infinite series of digits. We also can't deal with moments in time. So Laplace is talking about making a bunch of measurements at a moment in time. What is a moment in time? It's an infinitesimally small slice of time, and there is no such thing. There also isn't such a thing as a true mathematical point. Those things don't exist in our universe. They're abstractions that our mind creates. So what we'd have to do in practice if we wanted to try to predict human behaviour would have to measure the positions of all the particles in the brain within some degree of tolerance, to some level of accuracy, in other words. So we're not going to be able to say exactly where everything is and how fast it's moving and how fast it's accelerating or whatever, but we can try to say approximately where everything is during a small slice of time, which we could call a moment, although it's not really a moment. There's not really such a thing as a moment. And if we do that, we can hope to be able to measure everything accurately enough that we could predict human behaviour some time ahead. Because the further away we get from our various measurements, given that they are inherently inaccurate, then the worse our predictions are going to get that we've made using those measurements. We would have the same problem with the weather, for example. If we could measure all the temperatures in the world with, like centimetre resolution or something, the fact is there would be inaccuracy in our measurements, and any predictions that we made would get worse and worse the further away we get in time from when we made the measurements as a consequence of the inaccuracy in our measurements right at the start. We have that same problem with the brain, with the weather, with any kind of big, complex, interacting system. So you could ask the question, well, could we make good enough measurements to, for example, predict human behaviour like over the course of a decision that a person feels is made freely? Now, this isn't completely clear, I'll admit, but I would say no, that seems extremely unlikely that could be done even in principle. Because we have to get into the uncertainty principle in quantum mechanics. So we've got this idea that atoms are particles and they're made up of more particles, but take something like an electron. The more accurately you measure its position, the more you mess up its momentum. In other words, if we assume its mass is fixed, the more you mess up its velocity just by virtue of what you're doing in order to measure its position. And it's like that with basically all measurements in quantum mechanics. If you measure something more and more accurately, you mess something else up more and more as your accuracy gets greater with the first measurement. We've got these pairs of measurements which you cannot measure together. Measuring one thing always messes up some other thing. So if you try to measure the position of an electron very accurately, you will mess up its velocity. And you think what that means? That means that next time you make a measurement on it, you're not going to know where to look for it, because the uncertainty in its velocity is going to be so great because of what you've done to measure its position. If you could measure the position of an electron with infinite accuracy, you would then have zero knowledge about its velocity. Its velocity could be anything from 0 up to presumably the speed of light, but maybe even greater than that, who knows, because you can't, obviously this situation doesn't really make sense. You can't measure anything with infinite accuracy anyway. But if you could, then the uncertainty principle then would tell us, well, what you've just done is you've made a useless measurement, because you're not going to be able to repeat it. If you make a measurement and then that tells you nothing about what happens in the future, that is a useless measurement. It can't be used for anything useful at all. So you might think, people argue, well, we don't need to make measurements that accurately to predict human behaviour. I think you do. You have to take into account that the brain can sense individual photons. So the brain is also going to be sensitive to individual ions, parts of atoms migrating across cell membranes, for example. And this has to do with the way the brain seems to work. It's not clear, really, how people think. There's more that's unclear about it than there is that's actually clear, put it that way. Most of what a brain cell does is just not known or understood. But it seems as though the way the brain calculates things is neurons, brain cells, the ones that are responsible for thought, do this thing called firing, where when they get more than a certain amount of input, then they undergo, it's kind of like an electrochemical spasm, you could say, and then they send output. But that thing can rest on a knife edge, so you can see chaotic behaviour. That's chaotic in mathematical terms, with individual neurons. Tiny differences to what's going on with a neuron can make a big difference to what it subsequently does. So I think it's fair to say when you've got a massive bunch of neurons, like 1 billion of them or something, and they're all half the time resting on a knife edge, or maybe not half the time, but when they're actually in the business of firing, they get into this situation where just a tiny change can push them over the edge and make them fire. And you've got all of those networked together. There's no way, even in principle, that you're going to be able to make measurements with the accuracy you would need to predict future behaviour, even over the course of a matter of seconds. Now, there are experiments that purport to do exactly that, but usually even the people who perform the experiments would not say that those experiments disprove the existence of free will. That's something that kind of new atheists and people like that have come along and said after the fact. But one of the earliest of these experiments was performed by Benjamin Libet, I'm not sure how to pronounce his name, Libet, in the 1980s, and he found that if he stuck electrodes on the outsides of people's scalps and he asked them to make a decision, he could measure something he called the readiness potential, even 7 seconds. I don't precisely remember what numbers he gave, but let's say it was 7 seconds. 7 seconds before they actually made a decision, he could detect some readiness potential that he could use to predict what decision they were going to make. And the kind of anti-free will people will kind of leap on that and say, look, this is what we've been saying all along, this proves it. You don't actually need to get into quantum mechanics or chaos theory or whatever. You just need to stick some electrodes on someone's scalp or whatever, put them in an MRI machine, and you can tell what they're going to do 7 seconds into the future. Those experiments don't show this at all, and Libet, I don't think he thought this disproves free will, because the fact is people could change their minds at the very last fraction of a second. So the people themselves were reporting that they hadn't made a decision until just before they actually did make it. The readiness potential was saying this decision's been made seconds before that. But that's a very crude interpretation of it. Really what was being detected, I think, was just people kind of leaning towards making one decision. That's reflected in their brain activity. And then finally they say, okay, yeah, I am going to make that decision. They're giving it the rubber stamp and they're making that decision. But they haven't properly made the decision until they say they've made it, until that moment when they've actually concretely decided. And up until then, up until they press the button or whatever, that they had to choose, if they had to choose between two buttons, up until they pressed the button, like they've not actually made a proper decision. They could still change their minds. And in fact, the readiness potential, it only gives you a statistical prediction of what decision they're going to make. It certainly doesn't tell you what decision they're definitely going to make. And if you think about it, and you don't have to think about it very much to see that it's quite ridiculous to imagine that you could predict what someone's going to do 7 seconds in advance with any reliability. How would you be able to drive a car if your decisions were being made 7 seconds in advance? You wouldn't be able to do it. You got to be able to make split-second decisions to drive a car safely. You can't make decisions 7 seconds in advance. It's a ridiculous idea. But it's one of these things, like with some Christians, I'm not a Christian, I'm not religious, but I respect Christians and Christianity. I think as religions go, that's a good one, and some Christians will wheel out these alleged proofs of the existence of God, which I would say they're not proofs of the existence of God at all. If you're properly skeptical, if you adopt a logical approach, you insist on rigorous logic, there's no proof of the existence of God. But if you already believe in God, then these logical proofs are things that might help reinforce your faith. And I'm not dismissing that at all. If you are religious, that could be very important to you. But for someone who's not a believer, and someone who applies proper skepticism if you're going to treat it as a rigorous logical proof. Then it's not rigorous. None of these proofs are rigorous. And it's the same with this here. It's people have decided that they don't believe in free will, and then they adopt a very low standard of evidence for anything that seems to agree with their pre-existing idea. Now some people say, okay, quantum mechanics, it makes statistical predictions actually. So if you make certain measurements on a particle, and yeah, you can't measure everything with infinite accuracy because of the uncertainty principle, and also just because nothing can be measured with infinite accuracy except in certain very special situations. But okay, you can't do that, but the uncertainty principle gives you statistical predictions about what particles are going to do when you've already measured where they are and what they're doing now and what forces they're subject to. And some people say that disproves free will. Again, this is totally wrong. You imagine if you ask people what flavour ice cream they like, some people are going to say, I don't like ice cream. Some people say vanilla, some people say strawberry, some chocolate, and there's going to be a minority of people who cite some very obscure flavour. And if you've got enough people, you're going to get people saying they like a particular flavour that they've invented themselves and no one's heard of it apart from them, and so on. So if you did this repeatedly with groups of people and you tried to ensure that you were getting similar groups of people every time, I'm sure you could make statistical predictions about what flavour ice cream people are going to choose when you confront them with this question in your survey. But that doesn't mean they're not making free decisions. This will be a complete misunderstanding. Just because something follows a random statistical distribution doesn't mean that there wasn't a mechanism, or something harder to understand than a mechanism in this case, I suppose, behind that statistical distribution. And it's interesting that quantum mechanics in physics, it isn't quite mechanistic in the way that other theories in physics are. It doesn't necessarily purport to give you a mechanism for why things happen. It just says, look, you can make these measurements, and then if you make the same measurements or related measurements again, then this is the distribution of different outcomes that you're going to get with a big bunch of particles. That's basically what it says, and it's not telling you why that happens. So it doesn't tell you, for example, why radioactive decay occurs in atoms. Why it doesn't tell you why they break apart, but it can tell you the statistics of what's going to happen, or at least physics can in general. And that is really what science is. It's about connecting two sets of measurements together, and historically that would have been done, or people would expect to do that with a high degree of certainty. With quantum mechanics, we're getting into to statistics, and we're connecting two sets of measurements statistically, but that's still scientific, for finding correlations. That is what science is all about, I would say. It's not the whole story of the scientific method, but this is a key aspect of it. You don't have to assume any particular kind of causal mechanism behind what you're measuring to be able to correlate different sets of measurements. By the way, this is the Kavanagh district of Trieste. It's a kind of trendy district full of bars and cafes. Apparently when James Joyce was here, he used to hang around in this district a lot, but back then it was full of brothels and it was entirely different. Now it's kind of been gentrified, so there's no brothels here now, I shouldn't think, just cafes and bars, and it's pretty nice. Now I find in general all the arguments against free will existing, they're all this kind of thing. They take something that sounds intuitively plausible that can appeal to a certain kind of person, and they say, look, this argument disproves the existence of free will, when in fact if you were more rigorously logical about it, you would see that all it's doing is kind of increasing your faith that there's no free will. It's not actually any kind of rigorous argument against free will. Now, it frustrates people, I think, of a certain mindset, that it's hard to pin down free will. In fact, it's hard to pin down emotion. Why do we have emotions at all? What are they there for? And again, the same people who want to say that free will doesn't exist, they tend to say emotion is just an illusion, it doesn't exist or whatever. And by emotion, I'm not just talking about like big emotional states like joy, ecstasy, fear, sadness or whatever. A lot of neuroscientists will argue that everything that we do is attended by kind of subtle emotions, and people just differ in the level of awareness that they have of those emotions. And I think many Buddhists would say the same thing. And part of the practice of Buddhism is, I believe, like trying to attend to those emotions better, so you can kind of regulate them and understand them better. I'm not a Buddhist either, but something along those lines, because there are people who really struggle to understand themselves at all. But it does seem to be these emotions that are fundamentally making decisions, or they are involved heavily in the decision making process, put it like that. And if you think about it, you could be sitting in a house that's burning down. Your children could even be upstairs, but if you don't feel anything, you're not going to take any action. You're just going to say, yes, the house is burning down, fine. So why would you do anything about it? If you don't feel any emotion, you don't care. By definition, caring is about emotion. So you could be like logically programmed to rescue your children if the house catches on fire, like a computer, but we're not logically programmed like that. I mean, no one has really sat me down and said, John, if you ever are in a house that's on fire and there are children in the house, you need to rescue them. Well, maybe they have, I don't know, but I would be doing the rescuing because I felt strongly about it. If you don't feel anything, you're not going to take action, is my contention here. And anything that tends to reduce the amount of emotion that you feel tends to make you more passive. So if you take tranquilizers that reduce your level of emotion, you become more likely to just sit there, you become more unmotivated, and you don't do anything anymore. People who had lobotomies, which is a horrific operation, should never have been done, but they in some cases they ended up just sitting there not doing anything because they didn't feel anything anymore. So you need that feeling to actually take action. And yes, it does kind of boggle the mind if you start thinking about it in scientific terms, because people want to say the brain is a physical matter, which it is. And then if we've got this thing emotion, well, are we saying that emotion then somehow has an effect on physical matter? Because if so, that's never been proven. No one's ever found that to be the case. There are experiments in quantum mechanics that people misunderstand, and they think those experiments show that emotion is changing the outcome of the experiment, or at least observation. That's not the case. Quantum mechanics is a mechanistic statistical theory. There's no experiment in physics that has ever shown that emotion in any way has any kind of effect on matter. What you have to understand is that physics doesn't give us a prescription for what a physical system is going to do in every case. It may arguably give us a statistical prediction of what a physical system is going to do, but it doesn't tell you exactly what it is definitely going to do. there is totally room in there for some kind of a mechanism involving emotion to not alter the outcome but be key to determining the outcome. But I would actually say it goes much deeper than this kind of superficial analysis suggests. What we're doing here, by the way, is we're going into this car park. We're going to go to a lift, and the lift is actually going to take me to the top of the San Giusto hill in Trieste, and from there I can walk down and go back to the San Marco cafe. So there is this thing called the measurement problem in quantum mechanics, because physicists used to argue, nowadays they don't tend to argue so much because it seems fruitless, but they used to argue about whether particles actually were particles before they were observed, or whether observation caused them to, in a sense, become particles. The thing is that the equations of quantum mechanics seem to suggest that things do not have a state until they are measured. So a small particle, for example, like an electron, and no one knows why this doesn't apply to large objects, but let's say it does apply to electrons. According to quantum mechanics, an electron doesn't clearly have a state until an experiment is performed which causes it to have a state, like causes it to have a position, for example. So before you measure the position of the electron, it's kind of more like a wave. But once you perform an experiment to measure the position, that experiment itself physically seems to cause the electron to have a position. Now it is very unclear whether this is what's really happening or not. And there are various interpretations of quantum mechanics, none of which can be proven better than any other, but the different interpretations view this situation in different ways. You have to remember that an observation in quantum mechanics is a thing that can be made mechanically, at least it seems so, or at least that is true at a certain level. It's not a thing that involves consciousness necessarily at all. But then you get into asking, well, supposing we make an observation on an electron. Let's say we take the view, just from looking at the equations, because this is what they seem to say from a certain point of view. Suppose we take the point of view that the electron didn't have a position until it was actually observed by our apparatus. Then we have to say, well, why did any of the particles that compose the apparatus that we use to do the measuring, why did any of those have a position? And well, we've observed the apparatus consciously. We've looked at some meter or something and said, yeah, this shows that the electron is approximately in a certain location. But the conscious observation of it doesn't seem to be necessary. We could have recorded the results of the observation on let's say a sheet of paper automatically. That could have even have been done on Mars with some sort of Martian probe, and human beings might not have looked at the results of this experiment until like 20 years later or whatever, until it was sent back to the Earth. So when did the electron actually take up a position, take up a definite state? When was an observation really made, and why? And that's sort of an unanswered question in quantum mechanics. All kinds of physicists have all kinds of different ideas about it. None of them can really prove their case. So anyway, you might say, well, okay, quantum mechanics is clearly very complicated, and if you just think through logically the business of measuring the positions of things, and then you try to apply that to a kind of tightly coupled, chaotic, non-linear system like the brain, you can see that you're going to run into problems. So you could just say, okay, let's leave that aside. And you could say, well, decisions have to be based on something. If a decision is not based on anything, it's not free. And if it is based on facts, it's based on something, then it's also not free. So that disproves free will. By the way, this is the kind of area at the top of the hill where the Romans first made a settlement 2,000 years ago, which eventually became Trieste. We can see part of the castle there on the right. We just walked past some kind of Roman remains that we took a look at in the last video, and now I'm going to go down the hill here back to the San Marco Cafe. So there's an idea that all decisions, again, they have to refer to facts, and then you're going to process those facts somehow, and in theory that could be done with a computer program, and that's going to produce your decision. So again, you're trying to view the brain as a mechanism similar to something like a car engine or a computer, which have been engineered deliberately to behave in a deterministic way in all the regards that are considered important. That's a deliberate engineering choice. And of course, you could also say, well, if a decision is just made randomly, that's also not freely made. But again, if you start analysing that deeply, it falls apart. It's just one of those things that's superficially convincing. So for example, let's take an extreme situation. Let's imagine that I'm hanging from a rope. Never mind how I got into this awful position, but imagine that I'm hanging above a huge drop, hanging by my hands from a rope. Now, I don't want to die, so I don't want to let go and get smashed to pieces against the ground after a big fall. But also the pain is going to increase in my hands, and it's going to get harder and harder to hold on to this rope. Now, this is exactly a situation where you would expect free will to be exercised. You could argue that there is certainly a big element of compulsion about it as regards whether or not you let go of the rope eventually. Some people would probably be able to manage to hold on to that rope indefinitely. The hands would just freeze up in that position, they'd just stay there until they died. And in fact, this has happened. People have been rescued from those kinds of situations, and their hands have been painfully contracted around that rope. I remember reading a story like that, I think in a Reader's Digest, which my parents used to get back in probably the 80s. Now, if you wanted to make this decision or predict the decision that's being made, so when is the person going to let go, and are they going to let go? What facts do you have to take into account here? Maybe you could take into account the level of pain, but then you've got to sort of take into account facts about the person's life, because that's going to determine how willing they are to let go. How willing are they to suffer this awful pain, which is getting worse and worse, in order to save their lives? It's going to depend on what they think about life, and it's really going to be a battle of will. So I wouldn't say that that decision can necessarily be just based on hard facts. You could argue that it can be, but that's just an argument. It's not a rigorous piece of logic. So the idea that decisions have to be based on something, which means they're not free, well, what is that person basing their decision on? The thing that's really determining what they're doing, in large part, is raw emotion. It's pain, it's the desire to remain alive, right? I don't know how you would go about quantifying that. You could say, well, you can quantify it, but that's just you saying that. That's not some kind of piece of science that proves what it is you set out to prove. And interestingly, we see this kind of mechanistic view of the universe trying to assert itself in a kind of way that it just involves faith, really. You don't have to have a mechanistic view of the universe to be doing science. Science doesn't necessarily tell you why things happen. It's about predicting what will happen, sometimes only at the statistical level. And you can't always even hope to do that realistically. In the early part of the 20th century, there was this idea that it should be possible to prove all mathematical theorems or disprove them mechanically. So you'd have a bunch of axioms, so a bunch of propositions, basically, things that could either be true or false, and the whole of mathematics must just rest on those. Or if not the whole of mathematics, then surely at least the whole of arithmetic must have some axioms that it rests on, that it's based on. And then you should be able to create some sort of, in effect, a computer program, some sort of process that would then test the truth of all mathematical theorems on the basis of those axioms. That was the hope in the early 20th century. And actually, Bertrand Russell and Alfred North Whitehead set to work to begin the work of proving or disproving the whole of mathematics on the basis of axioms, and they started writing this multi-volume work, Principia Mathematica. And then in about 1930, Kurt Gödel, the Austrian mathematician, came along and showed with his incompleteness theorems that that was never going to work. You actually can't do that. You can't even prove or disprove every assertion that could be made about arithmetic on the basis of a finite number of axioms. In a second, I have to warn you, we're going to see some vomit. Look away from the screen if you don't want to see it. Apparently Sunday was a bad day to come here. Someone's thrown their guts up from the night before, had a little drinking party, and there's some screaming teenagers there, but never mind. You don't normally see that here. I just picked a bad occasion, apparently. So not only does this really mechanistic idea not work in physics, it provably doesn't work with mathematics either. The world's just not that simple. And no one is saying that Kurt Gödel's incompleteness theorems are anti-mathematical. They are. They're a wonderful addition to mathematics. They show us, in a way, what the limits of logic are. And logic does have limits that we have to deal with because we're in the real world here. And the arguments that would hold that free will cannot exist, they kind of remind me of the arguments people make when they want to say that you should be able to just write a computer program that would determine the truth of all mathematical theorems, that you should just be able to crank the handle there and figure out whether every mathematical theory is right or wrong. That's wishful thinking, and in fact it's just provably false. But people kind of argue in the same sort of a way over this issue of free will. They feel that the brain must be a mechanism, and that it should be possible to determine what everyone's going to do in terms of their behaviour on the basis of certain axioms and measurements, but it just isn't. That view now belongs in the past. There are lots of things, if we adopt a rigorously logical approach, which I think for anything scientific is a good idea to do as much as possible. There are going to be things that we just cannot prove or disprove. that we can't really say anything about. Consider the origin of the universe. You could say, well, the universe must have started at a certain point in time, but if you say that, it kind of begs the question, why? And then you're already thinking, well, there must have been something before the start of the universe, so what was the cause of that? And in the end, you're not going to be able to get at some kind of ultimate cause using rigorous logic. So this comes down to something called Münchhausen's trilemma. If you have a rigorously logical argument and you want to find the ultimate cause of something, logic has to work with axioms. It has to work with things that you take to be true, whether they really are true or not. For the purposes of your logical argument, you've got to have some axioms that you are taking to be true for the purposes of that argument. But then, why are those axioms true? And one possibility is you could prove them to be true using other axioms. But then, why are those axioms true? And then you would need other axioms to prove that those axioms are true. And you've got this infinite regress of axioms, which isn't very satisfying if you're looking for an ultimate cause. On the other hand, you could just say, look, my axioms are true. End of story, we don't need to look into it further. And in a way, that's what Christians would do, for example. With God, they would say, God created the universe, you can't explain God, end of story. And that's what we call a dogmatic approach to finding the cause of something using logic. Dogmatic here is not dismissive or anything. We're just saying we're just going to assert that certain axioms are true, and that's the end of the story. And we're not going to look into it more. We're not going to end up with this infinite regress, right? Another possibility is you could have a kind of circular proof, where you have some axioms that depend on other axioms, but those axioms depend on your first lot of axioms. That kind of is a bit reminiscent of views of the universe where you have a kind of circular time, where the universe is going to expand or whatever it's supposed to be doing according to this decade's physics indefinitely up to a certain point, and it'll shrink back to a point, and it will explode again and expand again. So you've got this circular thing going on. That's not a possibility. So if you're looking for causes of anything, and you're going to try to stick to rigorous logic, which involves axioms and then applying kind of formal logical method, you've got this trilemma going on. You're always going to end up with either infinite regress or a circular explanation or a dogmatic explanation. There's no other possibility if you stick to rigorous logic. And that is in a way kind of frustrating, but in another way that is how the world is, how the universe is, how our minds are, how logic is. And I think it's wonderful to know that. It's important to understand the limits of logic. You know, in the same way that if you've got, let's say, a hammer, you need to not run away with the idea that everything can be fixed with a hammer. You need to understand the limits of your tools. And that guy hanging from a rope that I was talking about earlier, he's going to be using reasoning as part of his decision process whether to let go or carry on hanging on and endure the pain. But that's just a tool that he's using. He's using logic, sure, as a tool. He's going to say to himself, for example, if I let go, I will die, because everyone I know of who's undergone a drop like this has died. So that's actually kind of a induction rather than deductive logic. But you get what I'm saying here. He is going to employ reasoning, but I would say it's a tool. And really it's his emotions that are ultimately making the decision. It's his will. So that's basically, I think, everything I'm going to say in this video, because soon we're going to come to the end of our walk, and if I start on another topic now, I'm going to end up running out of time. But we're on September 20th Street here. I think we've just kind of walk past the birthplace of Italo Svevo. I really need to learn more about Trieste if I'm going to be making these videos, because I've kind of used up most of the facts that I know at this point. There is a lot to know about Trieste. There are a lot of places that I'm going to be going in these videos, I suspect. I don't know how much longer I'm going to be staying in Trieste. Probably move from here before too long, and then I'm probably going to be walking around somewhere else, because my idea is basically to make these videos like probably one a week, and just to talk about stuff while I'm walking around, because I think it's interesting to see a town rather than me just talking about things. I did have a podcast in the past. I think I called it Quantum Lifetime, and it was about topics like free will and idealism, determinism and so on. And people keep messaging me even now asking me what happened to that podcast. The fact is, it all kind of accidentally got deleted. So I'm going to cover a lot of the topics that I did originally cover in that podcast. My intention is to cover them again in these videos, and this time put them on YouTube, where hopefully they won't get deleted. So now we're on September 20th Street. This goes on for quite a long time. There's a load of more cafes and bars down here, but we're just going to go around this corner just up here, and we're going to encounter the Cafe San Marco again. I read a book about Trieste by Jan Morris, and this book said that some rich guy paid to have this street made into a really nice street, if I remember correctly. And I couldn't find anything about that on the internet, but yeah, maybe some guy at some point must have decided, well, this street ought to have a load of trees on it and be a really nice place for people to sit. Well, I can't find out exactly how that happened. I got into thinking about free will just because I was interested in physics. I wanted to know, well, what's the real basis of physics? And that takes us really into metaphysics, although metaphysics has sadly become a word that people use to mean whatever they want it to mean. But really it should mean surely kind of above physics, or it should be about the foundation of physics and why physics is as it is. But people just use it to mean like absolutely anything, really. You know, if you're into healing crystals or whatever, you'll say, okay, this is metaphysics. I kind of think, yeah, whatever, that's not metaphysics to my mind. But anyway, here's the Cafe San Marco, and that's where we're going to leave it. Join me again next week. Please give the video a like if you enjoyed the video. Thank you so much.